Hey y'all, I found the one. I'm so excited. Welcome to day 6. We're going to be practicing linear algebra again. If you're new to the channel, oh no, I forgot to click go live on the vertical. Okay, so we're going vertically streaming as well as horizontally streaming. And if you're in the vertical stream, come over to the horizontal stream. Everything's better over here. So let's see. I found the one. We're going to be practicing linear algebra today again. And yeah, so today's day 6. The last 2 days we've been practicing linear algebra. I'm going to be rotating through a few different math subjects. To me, linear algebra is the perfect subject because it's both pure math and applied math. And then before that, I did number theory for a few days. Next, we might do calculus and analysis. I don't know. Probably. But anyways, if you've watched the last 2 videos, which I'm really proud of, go check them out. Especially the first 10 minutes of the scariest books are tiny video. I think that's a funny idea, and anybody can get something out of it. But yeah, if you check out those videos, you'll see. Oh damn it! They're all over there. But whatever. Let's keep them back there. I bought a bunch of new Dover books. One of them is Linear Algebra by Shilov, or Shilov. I should really look that up. I think it's Shilov. And it is a lovely book, but it is a pure math linear algebra book. So it is like for the graduate level or the upper division undergraduate, really like a second course in linear algebra. I was looking for first course in linear algebra. A friend sent photos of the first chapter's problem sets to me, and I was immediately like, yeah, this is the one, and I purchased it. Next time I'll have it on paper. I'm excited. So today, I just wanted to mention Strang to anybody who's new and following along, and maybe you don't know linear algebra, you don't know what that is, Strang. This is one of the most beloved linear algebra books of all time. There are some wonderful interviews. Like, Strang has done a lot of interviews. A lot of people have credited his MIT OpenCourseWare lecture series on linear algebra as like the thing that made linear algebra click for people. And I know that he just recently retired, but yeah, he's just one of the most beloved professors in linear algebra, and potentially because of the lecture series, but I've heard good things about the book too. In any case, it is the level of difficulty I was looking for, because I want the blend of applied and pure math, and I think that it'll have a good blend of the two. So yesterday I went to a coffee shop, and as I said, like I got the problems from a friend, and in an hour or 45 minutes or whatever it was, I solved 10 problems in a row, and it was like, yeah, one more, like let's do one more. And yeah, in the time that it took me to solve one Shilov problem, where I had to go back to the text and read the theory and take some notes and even learn a new technique for this old concept that I've known for a while. In the time that it took me to solve one Shilov problem, I solved 10 Strang problems without breaking a sweat. So that's not to say that I'm a math genius. I'm the farthest thing from it, but practice tip for everybody out there. If you are working in a subject, like I wish I knew this. I wish I had this idea when I was studying math as an undergraduate. If you're working problems from a hard class also be doing more problems from easier classes as well, or just find another textbook that's easier, um, and keep repeating those problems and the easier versions of the same problems or the same subject at the same time that you're studying the harder one. So, you know, this would be true probably in high school too. Like if you're in calculus and you're struggling a little bit in calculus and you notice that you're struggling with some algebra facts or trigonometry, like certainly, like get a trigonometry book. Get like a good, cheap trigonometry book. Dover has fantastic, cheap books. And work some trigonometry problems in and of itself. It's hard to learn a subject like calculus if you're also mixing it in with difficulty on trig or algebra, like working with polynomials. So yeah, and then same thing if you do study mathematics in and of itself. You may end up taking a second course in linear algebra, or if you're an engineering major, you'll probably take an engineering mathematics course that does a more advanced treatment of linear algebra. Pull out your old book. Don't sell your book at the end of the semester. I wish I knew that. Like, keep your books. Buy the paper versions. Don't get the digital versions. Screens are the devil. And yeah, just keep those books and come back to them and solve problems that you feel more confident in. So, you know, if you're working at level 2, also be working at level 1. And then later on, when you're working at level 3, also work at level 2 and level 1. And like just keep going up. I think it's just like the gym. So I just grabbed these like 5-pound weights. Like I can do a bunch of reps with 5-pound weights, but I can only do like one max deadlift, right, at the gym. So I literally, that metaphor works really well. I solved one Shilov problem in the time that it took me to solve like 10 Strang problems. So I'm excited. We're just going to be doing a lot of problems today. And there's my little rant at the beginning. I hope you enjoyed that. So let's get into it, shall we? OBS, Strang. I just wrote the word yesterday. Oh yeah, I remember why. Yesterday, 10 Strang in 1 Shilov. Lowercase s Strang, because Strang is tiny compared to Shilov. Alright. That was an accident. Alright, so let's just get started. Section 1.1 from Strang is on linear combinations, vectors and linear combinations. And I don't have the section, the theory. I don't have the rest of that section, but I do have the problem sets, and I think I'll be able to explain concepts as we go. So, hello, my name is John. Combinations. I am a former mathematics major. I studied pure mathematics 15 years ago. And then I put it away. I went and worked in software for a long time, like a lot of mathematicians do. And now I'm unemployed, or I'm just private tutoring because tech is going through a major downturn. I think that's the first time I mentioned that. And now I'm just rekindling my love for mathematics. This time around, I'm no longer attempting to pursue mathematics as a research career and becoming a professor. I tried to do that briefly and then realized I'm not good enough at the time, or I felt like I wasn't good enough. Who knows if it was imposter syndrome or what, but in any case, I could tell that would be a much harder path than learning to build iPhone apps, which I really wanted to do at the time. I was super motivated in the early days of the App Store to learn to build iPhone apps. And now I'm treating math more as a hobby. I'm doing it for fun. Like, I just enjoy it. I think it's beautiful. I think it's a great puzzle exercise, super similar to board games. I'm also a big board game fan, like of the modern designer board games. So, this may be the first time anybody has seen, or a lot of people, I should say, have seen the concept of a math hobbyist. I think a lot of people do not know that some people are recreational mathematicians who just do it because it's fun and it's beautiful. A lot of people only know math in context of trying to study engineering. You can study math in and of itself, and you can study math as a hobby, not to become a mathematician. And a lot of people have done that, including some very famous names that you might know. So that's cool, I think. That's one thing a lot of people haven't seen before and might be introduced to for the first time. So at least for these first few videos, I'm doing channel intro again and again because nobody knows this channel yet. It's brand new. So on the one hand, math, hobby, I'm a hobbyist. I'm going to be wrong a lot. But then also this is a practice stream. I've been doing a practice stream in my other deep hobby, classical guitar. Go follow at JC Practices. Shameless. That's a word I'm looking for. Shameless self-promotion. JC Practices, classical guitar. I've been doing a practice stream for the last 4 years on Twitch and YouTube, and I'm porting that idea of I'm just here practicing. I'm not an expert. I'm really not an expert in guitar, and I'm not an expert in math, but I'm good enough. Like, consider me as a peer, I think, and I am open to feedback. So let's put that in another color. Open to feedback. So please, open to feedback. Feedback is a gift. Quote unquote. I always like to say that because it is super true. Okay, the iPad isn't showing up correctly on the screen. Dang it. All right, let's get that to show up a little bit more correctly. Why? Oh, yesterday we had a horizontal iPad. Today we have a vertical iPad. Oh well. All right. I'll have to fix some OBS settings later. So this is going to be very sloppy, ad hoc. It's a live stream, y'all. This is not going to be perfect, highly produced content. Sometimes there's going to be asides. I hope you don't mind. Let's get into it. Nobody in chat yet, but that's okay. So let's find some problems and solve it. Exercise 111. Let's get started. What's going on here? I should have got my music going. We'll listen to music while we study live as well. But I'll set that up later. Okay, exercise 111. I gotta get my workflow working a little bit better. Okay. Under what conditions on A, B, C, D is the vector CD a multiple M of Luna! Hey, baby. Alright, so this is a great time to introduce this baby cat. She's so cute. She's a little devil. She will photobomb the camera all the time and distract us. She does not want me to practice guitar or practice mathematics. She wants attention. Hi, my loon. Hi, my baby. Alright. Okay. Ben H. Hey there. Alright, I will take a pause for chats because that's the most fun thing about live streams, right? Ben H. Hey there. How are you balancing doing maths and a job? You have an assumption there, sir. You have an assumption. Cool. We got chat working. Hey there, how are you balancing doing maths and a job? I'm thinking of studying more maths when I get a job in September. Great question. I have done that. You just need to get started, I think. Like, the hardest thing about any kind of side project, and I can talk about this for an hour straight some other time. The hardest thing about doing any kind of side project while working is just getting started and finding a way to have accountability, I would say. So I've been a classical guitarist on the side while working full-time jobs for the last 9 years. Accountability is fantastic and necessary in learning an instrument. You have to get a teacher. You have to have somebody that you show up to every week and say, like, sorry, I didn't practice this week. Work got busy, blah, 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 excuses. And it's the same thing in so many other disciplines. Like, people get into the gym and fitness, and for some people, paying a live, squishy, warm-blooded human to be their trainer, like, it's useful to pay for a private trainer because they are experts and will tell you the right exercises to do, but I think half the reason that you pay a trainer is just to be a coach who will judge you if you did not do your homework, right? So I think it's way harder, and I want to find a private tutor of my own for mathematics. I want to find a graduate student. I hope I can find a grad student through this stream who I can check in with and, like, pay for private lessons in math to learn math. So those are my 2 tips. 1, get started, track it somehow, which is like kind of a corollary of that. Track it somehow, like write out all of the exercise numbers. This is a cool time to show this. Write out all the exercise numbers somewhere and cross them off. This is what I like to do. Like, this is motivating. This is part of that just get started, just do it, and break that, if you know physics, like break that, what's it called, kinetic friction, which means, like, if you have an object, it takes some extra force to get it started because it's, like, kind of glued to the ground or whatever. That's not completely accurate, but whatever. This helps break kinetic friction in my mind. Rosen elementary number theory. Here's a little grid. Those are all the problems. I know that in section 1.1 I've only solved 2 from Rosen, but then I started switching to Andrew's number theory textbook, and I solved every problem from chapter 1 so far. I really like this method. So these are all the problems, and I know in my notebook, maybe this is a notebook where I solve some things about the Fibonacci numbers or not, or this is the book where I solved some problems from Andrews. So, great question. Okay, and then I forgot to complete the thought earlier on no job at the moment. I'm unemployed, sir. I am unemployed, sort of. I worked at Google, and then 2 years ago now, my entire team got hit with layoffs. Like, not just my team, but the team next to mine, and our vice president, like the entire organization I was in got hit by layoffs. And it is what it is. Like, just the whole tech industry is going through a downturn, and I have a lot of opinions there. But yeah, I have always had one deep hobby while working for the last 9 years. Right now I have 2 deep hobbies that I'm doing, classical guitar and math. And yeah, I'm just private tutoring. I love private tutoring. My favorite job to date was always running the private tutoring center. So, all right, let me read those last 2. This is exactly the problem. Maths is hard, and I really want some accountability, which my master's gives me at the moment. Ooh, what's your master's? Oh, are you a math master's student? Are you a master's student? You could be my tutor. I'm going to write this in big letters in case anybody else sees it. Hit me up. Starving grad students. Hit me up. JC practices at gmail.com. All right. If anybody sees... Oh, you are? Have you got an email? You're reading my mind right now. Look at that. So, yeah. What's the phrase that I'm looking for right now? Hobbyist seeking coach. That's what I'm looking for, like, I don't know, like a dating site or something. Hobbyist seeking coach. All right, that was fun. So let's continue. Yeah, hit me up for real. Send me an email. What I think would be really dope would be somebody who wanted to do live lessons here on YouTube. I think that would be phenomenal. I've been doing that with my classical guitar teacher, and it's working really well for us. Like, I really, really love sharing our lessons together. So, and I think it could be very win-win for everybody involved. Okay, so accountability, which my master's gives me. Doing Galois theory after a day of work sounds hard, lol. Also, interacting on YouTube is minus sign. Maybe you meant to say interacting on YouTube is so cool. It really is. YouTube is fun. YouTube can be a beautiful, delightful... where is my book? Well, whatever, I lost it. But I have Arden's Galois theory nearby, and you're going to really like my video from 2 days ago. It's kind of long, but just watch the first 10 minutes. I talk about how the tiniest, or the scariest books are tiny, which I think is a fun saying. Let's see, where the... Oh, here it is. It is here. It's here, and I've got Sarah's course in arithmetic floating around here somewhere. I just picked up this Dover book, and yeah, I just had a video a couple of days ago about how the scariest books are tiny, this book is scary to me. There's no exercises in it. That's scary. And I know that that's the book that like Lang, references and other things like that. All right, let's get back to it. Yeah, please do send me an email. What are your, you say Galois theory. What are your research interests? Or like what are your specializations? I personally am a algebra fan. Now, like, I don't know. I would like to work on analysis again, but algebra is my thing. And someday I want to get into type theory. That's how I found your videos, actually. Cool! Because I was like, I have the Shilov in linear algebra. I get the same vibe from algebra? From Algebraic Topology by Maunder. I haven't even heard of that one. Neat. Okay, cool. Yeah, I just picked up Shilov. It's beautiful so far, but it's a single deadlift for me because I'm very rusty. I have taken, a second linear algebra for math majors course a long time ago, but that's not the book I wanted. I wanted a 5-pound weight book instead. I don't mean to be an asshole to anybody who's studying Strang for the first time, because I remember some of this stuff was hard for me to wrap my head around the first time around, but then later on you get stronger and you can solve these quickly. All right. So here's an example. I'm just going to write this part, but I'll tell you all that, like, here he doesn't even use the word hint, but basically he then has another entire sentence that's like hint ... You know what? Let's do it. Under what conditions ABCD is CD a multiple M of AB, and then the next sentence, start with the two equations C equals MA. Okay, it's a little unfair to center that part stylistically. Start with the two equations C equals MA and D equals MB. By eliminating M, find one equation connecting A, B, C, D. You can assume no zeros in these numbers. Okay, so no offense, but like, yeah, for me this is all I needed. And then all of this was like kind of an unnecessary hint that I wish just started with the word hint, : because there's nothing wrong. It's very good for authors to give hints on exercises, but if you don't need the hint, if like you only read the first part and you're like, I think I know what that's asking. Let me try it. If I don't see the word hint next, then I start thinking, oh, maybe there's like a sub-problem. Maybe there's like something more, like maybe this is just part 1 and then there's a part 2. It's like, and then do blah, blah, blah. And then what about in this other case, XYZ or something? But no, this is actually just a hint, like how, like what, he's clarifying what does this first sentence mean. So over time you don't need that as much anymore as a student. So I really want to make sure I'm not talking down and saying like, that's too easy or something. But other books will start with the word hint, so it tells you as the student, like, go ahead, try to do that first part on your own, and if you get stuck, read more. Anyways, and that there's a study tip for everybody. Like, try to solve the problem without reading the hint if you can. And if you get stuck, that's a good thing. The author expected you to get stuck. That's okay. All right. Anyway, so when does CD equal M times AB? I did these in the coffee shop yesterday, so we'll see if I get them all correctly. So now, if C is a multiple of AB, then Strang is really teaching like this like kind of matrix operations that anytime you have a vector, you can multiply it by a scalar. So anytime you, let's also draw, a vector can be thought of as a pair of numbers, x, y, that has a direction. So this one has this direction with this angle here, and a length. So in physics, you use vectors to show the force of something, like the force of gravity is pulling a baseball down to the center of the earth, with a certain amount of force, like the certain amount of the length is like the strength of gravity, and the direction is down. So if you have a vector, you can multiply it by another number, including negative. So we can multiply that vector by like negative 3 or something. And so that is like what this multiple here is. All right, let me read a couple things. My thesis is in branching processes, but I'm also into analysis and algebraic topology, but getting more into algebra at the moment, lol. Yeah, I've always imagined that you would have to be into algebra to some degree to learn algebraic topology. What I think would be so dope if you wanted to be my coach, like, I've never learned any algebraic topology, and I've always thought that that would be wonderful to learn. Yeah, like, there are those videos, I forget what the channel is, but, you know, like explaining a concept to like 5 levels of difficulty, like explaining to a kid, explaining to a high schooler, explaining to an undergrad, a grad student, a professional, and then a master or whatever. I would love to get your like, explain like I'm 5 and explain like I'm a rusty undergraduate about algebraic topology. And what I think is cool about this whole practice stream YouTube channel idea is that we can go off the beaten path. I don't need to jump right into Hatcher to learn algebraic topology. Like, I can just take little bits here and there, which I think would be cool. Hello, what's your opinion on math Olympiads? Never heard of it. No, I've heard of it, but I have never done them myself. They sound cool. I wish I did any kind of competition math or math club or anything like that in high school. I didn't come to appreciate and love math until I was an engineering major in college and then switched to math. So yeah, I don't know. I'd like to learn math Olympiad style problems and math. I'd love to get like a private student who wants to to solve math Olympiads or compete. The closest one I did was a Putnam, and here, this is a good aside on competition math. Competition math. I want these videos to be accessible to everybody. So something like this is flavor that I think a lot of people could pick up on, even if they don't know what linear algebra is. There are math Olympiads. Which in my mind is like high school math, like high school competitive, difficult math, like for math club or something. That seems great. There's my opinion on it. And then there's the Putnam exam, which is university or like undergraduate, I think. I think you have to be an undergrad. Not sure if that's true. You at least have to be a student. I'm sure of that. And this is kind of like the math Olympiads for university students, and it's hard as fuck. I think I got 8 out of 100, and I was thrilled. I was so happy to get an 8 on that test, which is crazy. Most people get a 0. That is literally true. The median score is 0 from what I remember on the Putnam, meaning most people get a 0. It is 10 problems, and I don't know how true this is, but I heard that the only scores that you can get on problems are 0, 1, sometimes a 2, 8, 9, or 10. Like, there's no in between. So getting an 8 probably means that I had most of an answer. I had the right idea on one problem out of 10. And it was fun. It was just a great experience. So that's what I can say about the Putnam. That's what I can say about Math Olympiads. I took the Putnam, and it was fun. So I recommend doing the Math Olympiads. I think that they would also be fun. There's my spiel on competition math. Let's keep going. We're back to Strang. This stuff is good. It makes me feel like this rusty cobwebs machine is working okay. I remember some of this stuff. All right, so now we have CD equals a multiple of the vector AB, and in linear algebra, I'll talk about this in the future, but this property that you can move the multiple into the vector is actually one of the most important details of linear algebra. I'll probably talk about that next time. All right. I'm fixing something on the vertical stream. If anybody's watching the vertical stream, come join us in the horizontal stream. It's much better. Everything is better in the horizontal stream. All right. So the fact that you can move the multiple in and then the vector CD equals the vector MA, then that means that we have two equations, C equals MA, and we have the equation D equals MB. Now, from here, since we want a single equation relating A, B, C, D, which maybe I was biased to knowing that through the hint on Strang's exercise statement. Then I know that what we can do is we can eliminate M. So M, let's take the first equation and say that M is C over D. I'm noting that right now, this is where we use the assumption that D is not 0. And then if M is C over D, then we can rewrite the second equation. D equals C by D. Wait. Oh, I screwed that up. M equals C over A. Handwriting. This is what paper is better. C over A. D equals C over A times B. D equals C. I like alphabetizing things. BC over A. Then therefore, multiplying both sides by A, AD equals BC. I think that this is the one beautiful equation that Strang is looking for as our solution. Cool. Now we're done. Let's move on. Let's take this a little bit better. Can I share an elegant, I think, way I'd approach this? Never mind, it wasn't much more elegant at all. LMAO. Nice try. Nice try, though. I like it. It's always good. So, like, what you're saying is kind of what I'm about to say. Once you've solved the problem, like, tip to former self, go back and, like, oh yeah, I remember he said that you can assume no zeros in these numbers. Like, that was a restriction on the problem statement. Can I try solving this problem a different way? Can I relax one of the assumptions? Like, that's not assigned in my homework set, and I'm not going to get any credit for doing that, but I'm a hobbyist, so nobody's even grading this. I get the opportunity to just go a little bit farther. And if I were speaking to former undergrad me, I would give the tip, like, try to relax assumptions and solve problems that weren't even asked in the problem set. So what if we didn't make this yellow assumption that one of the numbers is not zero? Like, notice we only use the fact that one of the numbers is not zero, right? I wrote D, but I meant to say A. Can I assume that just one is not zero? I don't think so, because I'm also going to notice, like, here I made a decision to solve for M in the first equation, but that was a decision I had to make. I could have chosen to solve for M in the second equation, in which case we would have gotten M equals D divided by B, right? So maybe here we also need the assumption that B is not zero. But wait a minute, like in this equation, if either one of them is zero, then the other side is zero, right? So can we relax the assumption that one is not zero? Like, I'm not sure if I'm being completely clear on this, but I'm just going to come up with examples to myself, like, okay, 2, 0 is 2 times 1, 0. That didn't need the assumption that that none of them are 0, right? Or obviously same thing with 0, 2. 0, 2 is 2 times 0, 1, or 0, 0 equals anything times 0, 0, right? So maybe it's something like here, this assumes that the first vector, Strang likes to use v and w, so I will use v and w as well. V does not equal w, or it's either true that v is not w or v is w is 0, 0. I think that's true. And then over here, if v is not w, then AD equals BC. So if all are not equal to 0, like they could all not be equal to 0, or if one of them is 0, then another one is 0. If all are not 0, what am I trying to say? If all are distinct, then none are 0, or the second coordinate is 0 in both, and the second coordinate is equal to both. Okay, I may have lost everybody. Let's go on. Next problem. All right, any questions? What's going on? How's it going, folks? I want to rip through way more than we're doing right now, but it is good to explain, at least as we go, a couple of them. This is a math practice stream, everybody. It's not going to be super polished. Going around a triangle from 0, 0 to 5, 0 to 0, 12 to 0, 0. What are those three vectors U, V, W? I should note that in Strang he uses a bold font for vectors, but that's a little harder for me to do. I guess I could technically change the pen size, but I'm going to use little arrows to make that explicit when I need to, and then other times I'll just ignore it and we'll just assume that that variables are vectors. Hey, Sneha, I'm glad that you're enjoying this. This is really fun. It's fun for me too. Thank you for watching. All right, so where are we? What are those three vectors? There was a full sentence. I see that there's more. I'm going to go ahead and just jump on this, and I know what a triangle is. I know what coordinates are. Let's see if we can get started. So we've got a vector here. We could draw the arrow wherever the hell we want to. I'm going to draw it at the end because the textbook does it there, I think. But actually, no, I'm going to be a smart ass. And because I think it's going to make the triangle look neater. So we've got a vector going from 0, 0 to 5, 0, and then 0, 12. This one's longer than the other one. and then 0, 12 to 0, 0, right? So there's the path that Strang is describing around a triangle. What are those three vectors? Okay, I guess he's saying that U, V, W are those in order. Pretty sure we got U equals 5, 0. V equals, so now we went left 5 units and we went up 12 units. So the vector V is negative 5, 12. Here's a good opportunity to point out that that vector is the same. It's like parallel to this vector over here. If you draw a vector from the origin, then you can see that the x-coordinate would be negative 5. UVW. W is no change in the x-axis, and it's 12 units down. So it's just the same as this guy. Okay, all right, so I think I answered that first question. What's next? What's next? Let's get through a lot of problems. Oh, yeah, okay, so next part. What are their lengths? Ha! U and V and W. We're in the 6th edition of this book, and this is ugly. Come on, Strang. Come on, Strang Publishing House. Use a comma. We're adults. All right, so the lengths are exactly the same as the lengths in a triangle. So it's great that he chose this example with a triangle to motivate and like get us to practice and learn vectors like with a triangle, because a lot of us remember this beautiful equation: a squared plus b squared equals c squared for a right triangle. And you may or may not remember that this is a special right triangle with integer solutions. 5, 12, 13 is a lovely one, and 3, 4, 5 is another one, and I don't know any others. But if you didn't remember that, the length c, in the Pythagorean theorem, we've got the square root of a squared plus b squared. So anyways, like I think it's pretty clear to see that from 0, 0 to 5, 0, that's 5 units, and then from 0, 0 to 0, 12, that's 12 units. So pretty sure that that's the length of those. And then the length of the third side of that triangle then is going to be the square root of 5 squared plus 12 squared, 25 plus 144, ask ChatGPT, and it'll hopefully tell you that that is 13. Okay, so let me catch up on chat. This is really fun. Hey, man, I'm so happy to hear that you like it, Sneha. Also, Randa, but I noticed how you got How to Prove It by Velleman in a previous video. To anyone else watching, that book is incredibly useful for transitioning to university level mathematics. Great tip. I haven't opened it yet. I mean, I skimmed through it, but I have not read any of it. Here. But just exactly like Strang's book, which we're working through for linear algebra, for intro to linear algebra, I've only heard glowing praise for this book. Like, this book is universally loved, and I'm just gonna say it. Like, from what I've heard, this book is a work of art. The way that Strang's book is a work of art, the same way that other books are all works of art. And it's like touring the Louvre and seeing the Mona Lisa. So I look forward to seeing the Mona Lisa of How to Prove It. I'm looking forward to that. Thanks for the comment. I've been preaching about that book for years. Yeah, you and everybody else. I'll try, but I'm a high schooler. I believe it might be too advanced for me. I don't think so. Oh, I don't know, Sneha, if you're talking about this stream or that book. But either way, I think you got this, dude. If you are interested in Math Olympiad, you're going to want this book, I think. And we can work on it together. Like, soon, maybe the next set of streams, we're going to be introducing more and more proof techniques. And we're going to be working through this book and others. So, just stay tuned. Hit the like and subscribe. Just do it. It takes 1 second, everybody. I don't know if you have yet. I don't like to watch my analytics while I'm live. But just hit the fucking like and subscribe for a second. I agree. Very grateful to it. Yeah. Awesome. Yeah, I hear great things. Cool. What else? Lengths. UVW. Were there any other questions? I have to pull it up. Okay, no more questions. Yeah, it just said, what are their lengths? And then it defines here. The length, because I saw that there was another sentence in this problem. The length squared of a vector u equals u1, u2 is double bar u squared equals u1 squared plus u2 squared. Cool. So reading that, I remember yesterday when I worked these problems, I thought, cool, I wonder if, because I literally do not have the theory section. I just have photos of the problem set of section 1. I wonder, is this a definition in an exercise? Or is it a reminder? Sad face. Happy face. I'm being a snarky asshole right now. But like, the only thing I want to say here is that this is a really neat, elegant, lovely thing that a lot of advanced math books will do. Instead of introducing some concept and introducing every single concept in the section, in the theory, some books, more advanced books, will, and I consider this an advanced technique. So that's why I'm like, oh, that would be really cool if he's on problem 2, jumping into like an advanced math writing, math teaching technique or something. Like, I'm reading this book with like a little bit of a meta mindset of like his presentation of linear algebra. Yeah, like introducing the idea of the length of a vector being defined as this. Like, is this the definition that he chose? Like to put it in an exercise? That's great. That's great. If so, so if we worked directly from this definition, then we wouldn't. I mean, it's not that different, but like remember that I started with this square and I just saw that the length was 5 of the first one, and then the length of this one was 12. Like, but if we work directly from the definition, what we should be doing is saying that the length of u squared equals the first coordinate squared plus the second coordinate squared. So the length of u is the square root of 25, which is 5. And that's perfectly correct as well. And that's like a little bit more careful and a little bit more rigorous. Whereas I'm being sloppy over here a little bit, sort of, kind of, or whatever. Thanks, liked and subscribed already. Thanks, man. I appreciate it. Thank you. Genuinely very grateful for that. It helps. It really does help for a new channel. This is a brand new channel, everybody. All right. Now we got this nice little statement. Problems 3 to 10 are about addition of vectors and linear combinations. So I introduced yesterday the idea of linear combinations of vectors. In particular, I was showing how the determinant of a matrix A is 0 if any row is a linear combination of the other rows. In the example we had, that was delightful because I was wrong the first time around. The example was this: 4, 5, 6, 7, 8, 9. That the determinant of this, I said, is this special tool that tells you if a system is solvable at all. And 2 videos ago, I claimed that that is not 0, but I was wrong. I embarrassed myself on the internet. And that's because 2 times 4, 5, 6, writing it as columns the way that Strang does, 2 times 4, 5, 6 minus 1, 2, 3 actually is, right, if we're super careful, just for everybody, 2 times 4, 5, 6, we can multiply a scalar, we can stretch and lengthen a vector going in the same direction. This is 2 times 5 is 10, 2 times 6 is 12, 8, 10, 12 minus 1, 2, 3. 8 minus 1 is 7, 10 minus 2 is 8, 12 minus 3 is 9. And what? Oh my god, this random example that I completely pulled out of my ass. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, there is a linear combination of the first 2 rows that equals the third row. That's delightful. I'm never going to forget that. So that's super cool. And then we also tried to twist this example, and we wondered, okay, what about if we wrote that matrix differently? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that gonna, what about that? And then magically we found again R3 equals 2R2 minus R1. So again, we had another linear combination of rows. Without even running through all the numbers, we know that this fancy machine, the determinant is 0. That was a really nice moment in the last 2 lectures, videos, streams, practice sessions. I'm going to try to use the word practice session. Okay, let's state the next problem. Problem 3. So that's linear combinations. Describe geometrically line, plane, or all of R3 all linear combinations of A 1, 2, 3 and 3, 6, 9. Okay, what the heck does that mean? So I like to draw a picture when I can, and I like to think in 2D space rather than 3D space. But I see that 1, 2, 3, or 3, 6, 9 is 3, 6, 9 is 3 times 1, 2, 3, right? So I'm pretty sure that means that this is a line. And we could go back in the theory, in the section and the description, the theory of this section to see exactly why it's a line per Strang's treatment. But let's get let's create an example for ourselves and draw in 2D space 1, 2 and 3, 6. All right, so if I'm very careful here, 1, 2, 3, 1, 2, 3, 4, 5, 6. And then I'm going to draw another, let's just stay with the same color. I'm going to draw another vector going to 3, 6 and draw the line down to the origin. Yeah, exactly what I thought. The second vector is a multiple of the first vector, so therefore this is going to create, in some sense, the combinations of these two is actually just all of this line in that would be an R2. Now, in 3D space, because I think I might be wrong on what I was saying. We have 2 points. No, I'm right. I'm pretty sure. We have 2 points that are a multiple of one another. This is harder to draw on in 2D, but like imagine that that this is coming out somewhere with the third axis. So we have 2 different points, again, that are where one is exactly a multiple of the other. So I think that, again, when you add those, like combinations of those, it's just going to be a line in 3D space. Yeah. So because the second vector, v, is 3 times the first vector, u, then we have we only have one independent vector in 3D space. So one vector in 3D space generates a line. 2 vectors in 3D space, 2 independent vectors in 3D space generates a plane, and 3 independent vectors in 3D space generates everything, generates all of R3. So that's cool. Pretty sure that if I read the theory, if I read the section, it would state that. But yeah. Hey, Jeffrey, how's it going, man? Jeffrey is a longtime regular of my guitar channel. It's good to see you, dude. How are you? I don't like seeing all these like little profile bubbles. Let's get rid of those. Too much color. We're mathematicians here. We like austerity. All right. That's just a little bit too big. Or maybe, ooh, whoops. I wish I could Command Z. Oh no, I can't Command Z in OBS. Good. Okay. This is going to be better because the black blends into the black. And I don't want that scroll bar on the right-hand side. Let's crop that. We'll get rid of that. Okay. That's a little bit better, I think, right? I could put it in between these text boxes. Sorry for getting distracted. How's it going, Jeffrey? Hey, tonight, I don't know if you can make it tonight, but I'm going to run my next guitar recital at 8 p.m. Hope to see you there or in the VOD comment section if you can make it. But if not, no worries. All right. What's going on next? Where are we? This is fun. I'm having fun. I solved all these much faster yesterday when I wasn't yapping the whole time. 1, 0, 0, and 0, 2, 3. Okay, perfect. There is no number m that I can multiply with 2 to equal 0 other than m equals 0, right? If 0 equals 2m, then the only option is multiplying by 0. But then, what am I saying here? No, wait, I got this backwards. What am I trying? I'm trying to say there's no multiple m that I can multiply with 0. Like, I can never write this first vector as a multiple of the second vector. This is impossible. That's what I'm trying to say. This is impossible. 2 is never 0, right? So these 2 vectors are independent. Therefore, because they're independent, and two independent vectors in R3 generates a plane. Then they generate a plane. All right, part C. Jeffrey, let me know. Have you studied math in the past? Have you seen linear algebra before? And if so, what do you think of the stream so far? And if you haven't seen linear algebra especially, what do you think of the stream so far? 200, 022, and 223, right? I can see that these two are independent for the same reason as the last problem. And I can see that these two are independent as well. Yeah. Those are independent. We've got three independent vectors. This generates the world. Next problem. Number 4. Draw V equals 4, 1 and W equals -2, 2. These are cool problems. I remember thinking, oh, this is a nice problem. I like this. And V minus W in a single XY plane. This is a nice problem to introduce all this stuff, right? 4, 1 is going to be something like this. -2, +2 is going to be something like this. I'm going to label these V and W. And now we need to find V plus W. And let's just write that out. What is V plus W? We add coordinates separately. So 4 plus -2 and 1 plus 2. What is V minus W? 4 minus -2 and 1 minus 2. Cool. So now we're going to add V plus W right about here. And V minus W, I don't know, somewhere like here. Beep. Love you. Some math on YouTube. This is interesting today. Yeah, man. Yeah. Why not, right? Like, classical guitar is niche as hell. Classical music, like, is boring to most people, right? Math is boring to most people. I'm a boring guy. I have boring hobbies. But I think that it can be really fun to the right people, you know? I think classical guitar and math can both be fun. Fun as heck. There are those. Next problem. If V plus W is 5, any questions? Any questions, everybody? Oh, you know what? My coffee got cold. Oh no. Dang it. I've been yapping too much. So my coffee got cold, and now's a good opportunity to mention there's a joke in mathematics that mathematicians are machines that turn coffee into proofs. That's an old saying. That is me. And then there's another joke about Erdos that I'll tell another day. All right. If v plus w is 5, 1, gotta pull up the other app again. Where are we? If v plus w is 5, 1 and v minus w is 1, 5, compute and draw the vectors v and w. I like it. V plus w, we have v plus w and we have v minus w. Therefore, we know that v is going to be, if we want to solve for v, what can we do? We can add those two together, v plus w plus v minus w. If we add those two together, then we get 2v, right? So then, since that's 2v, let's divide by 2. Yeah, that's it. So that's how we're going to construct v. And if we want to solve for w, it's going to be similar. We're going to have v plus w minus v minus w divided by 2. Cool. Let's calculate those. V plus w plus v minus w divided by 2 is the same as 1/2 times 5 plus 1 is 6. 1 plus 5 is 6. So now we have the vector 3, 3. And now v plus w minus v minus w divided by 2 is 5 minus 1 is 4. 1 minus 5 is -4. And our solution is 2, -2. Cool. We're going to draw those. Three, 3. And -2, -2. Something like that. Maybe that one's a little bit longer. Neat. So v and w are multiples of one another. Okay. And so they generate a line they generate the line y equals x in, oh wait, no, what am I doing? I got that wrong. I was like, wait, I don't remember that being the case. Okay, so v is this vector, and then w is +2 minus 2. So +2 minus 2 would be something like this. There we go, okay. I felt like that's an odd example. Okay, yeah, so now they generate the plane all of flatland. I heard a classical guitar piece on the radio the other day, and listening to you practice really improved my listening experience. Dude, Jeffrey, that means a lot. I'm glad that you enjoyed it. First off, what are you doing listening to the radio? Like, I didn't realize you were that old. And really, they're playing classical guitar on the radio? That's awesome. Do you remember what piece it was? That's like super cool. Yeah, thank you. Thanks. Means a lot. Next problem. Don't copy my solutions, kids. I'm going to be wrong a lot. Maybe I'll even throw in some incorrect math here and there. And if you do copy my solutions, give me credit. Tell your teacher. Say that you got a hint from the math hobbyist on YouTube. And tell them to like and subscribe. Find the components CV plus DW, 2C plus D, and CV plus DW, 2D. Okay, done. Number 7. I gotta go somewhat soon. Compute U plus V plus W and 2U plus 2V plus W. How do you know U, V, W lie in a plane? This I found really kind of confusing, because then I was like, is it asking about the prior U, and is it asking about the last V and W from the last problem? Like, where is U coming from? And then I see that the next sentence then starts, these lie in a plane because W equals CU plus DV. I read that sentence and I'm like, wait, what? Did you just answer your own question right here? How do you know? And then it's like, the book is, like, this is indented. How do you know UVW lie in a plane? These lie in a plane because that's the next thing that you see. So it's like, I'm confused. What's happening? And then right after that, here's a part that I was really looking for. 1, 2, 3. It's like, I was ready to go. I was like, let's go. Let's calculate. I know how to do U, V's, and W's and add them together. Now, like, I would have expected this to be stated before everything else. Like, if U is this, V is this, W is this, then calculate. Like, I would have expected this to be first, this to be second, this to be third, and I would have expected the word hint. So, part 2, compute UVW. Added together. UVW, 1 minus 3 plus 2, 0. 2, 1 minus 3 is 0. 3 minus 2 minus 1 is 0. Cool. 2U plus 2V plus W. Alright, so 2 minus 6 plus 2. 2 minus 6 plus 2 is negative 2. 4, 4, 6, 3. 6, 0. Oh, wait, no. Blah. 6, 2, 1. 2, negative 2, 3, 1. There's our answer. So here's a nice little aside. I doubt that. I think people see what I was just doing there. It's a tip that I just got reinforced from this book. This book really reinforced this tip. Like, if you're doing mental math, don't try to think 2 times, like, let's look at the second problem I just did. 2 times u, 2 times 3 is 6, plus 2 times negative 2 is 6 plus negative 4, which is 6 plus negative 4, which is 2. 2 plus negative 1 is 1. Like, that's a lot of words. That's a lot of, like, little intermediate steps. Try to think, you see the 2 from 2u, and you see the 3 from u, and you think 6, and then minus 4, 6 minus 4, in my head I have 2, minus 1 is 1. Like, things like that. Like, instead of saying 2 times 3 is 6, think 6. You see 2 and 3 and you know you're multiplying them, just think 6. This is such a nice stream to have on while studying, by the way. Kind of like a maths ASMR. Hell yeah. That's the goal. That, like, Jeffrey has been part of my classical guitar stream, and it's the same thing. It's like the exact same idea. Like, people have said that about hearing me, just listening to me practice scales. And they're like, I love to practice scales with you. Some people like that. So if that sounds interesting, y'all should go check out. Like, if you enjoy this, you may also enjoy my guitar stream as well. I don't know which one I would pick if I had to pick. It's like picking between your favorite children, right? YouTube.com/JCPractices. It's a similar thing. It's meant to be like a classical music ASMR, classical music practice. So, like, I will... people will be scrolling the YouTube Shorts feed, which is also happening right now. People are scrolling the YouTube Shorts feed, and they're getting, like, 30-second TikTok dance videos. 30-second videos reposted from TikTok, and then all of a sudden, bam, you've got an classical guitar scales practice session where I practice scales for 1 hour straight. Or we're doing math. We're literally doing math for 2 hours and solving problems. To me, it's just delightfully like the opposite of a YouTube short. Which I just think is funny as hell. Like, I don't know. I like it. I like the idea. I want to see more people create a practice stream just like this. Like, please, if anybody sees this, rip me off. Like, I want to see... I'm a hobbyist, so I have no ego in the game about guitar or math. I would love to see an undergraduate learning from Strang, working these problems for the first time, being vulnerable enough to solve math problems live on Twitch and YouTube. Like, I want to see people who are undergrads doing the exact same thing. Like, we've got enough space in the world for multiple streamers. I would love to see your practice stream. Like, I would really love to see your practice stream, Ben. Like, an algebraic topology practice stream. Like, I will understand none of it, but if you just talk out loud while you're, like, studying your math, like, it'll be a math ASMR, and I'll understand a tiny bit of it, and then somebody else will understand none of it, but both of us might enjoy it as an ASMR thing. You know? All right, Jeffrey Boyle said, WRTI in Philadelphia, Pennsylvania plays classical during the day and jazz at night. Nice, nice, nice. Yeah, I really like those classical music. So it was actually a proper classical music radio station. Yeah, like NPR does that a lot. That'd be sick. You should do it, dude. Like, I want to see more practice streams. There's at least one guitar and violin practice stream that he says was inspired by my classical guitar practice stream. So I think that's super cool. And I'm also lifting or like taking inspiration from others on Twitch and things as well. I haven't seen a math practice stream yet, though. Like, I think it's a cool idea personally. Like and subscribe. Let's keep going. Let's keep going. That'd be sick. Yeah, and then like it can just form a beautiful, fun little community of people, you know, of like-minded people, all trying to like help one another. There's a really cool community building around classical guitar, I think, of like hobbyists, like people who are just hobbyists, or but it's like a mixture of hobbyists and semi-professionals and legit professionals. I think it'd be really cool to build a similar community for math, like pros and hobbyists kind of together, which is a great moment to plug my Discord, discord.jcpractices.com. Go to that link. Easy to type in a web browser. Discord.jcpractices. My name is John Crossley, so jcpractices.com. Let's keep going. Focus. We got to focus. I want to get through 10 problems. I want to get at least one problem I have not worked yet. Let's just jump right to it, because I think I worked 8, 9, and 10. Let's just jump right to some that I have not seen. Ooh, wait, no, I didn't do 10 yet. I did do 9. 9 was nice. I wish I had time for 9. Maybe we'll do it after 10. I like this. I see 10. It says, not easy. Ooh. Okay. How could... I like that. How... All right, not easy. I have not seen this yet. How could you decide if the vectors v u equals 1, 1, 0. Brief aside, I really like that Strang keeps like interchanging. I like that he interchanges the notation between column vectors and row vectors, and like I don't know if I've seen him use brackets, square brackets for the row vectors, but it's the same damn thing. Like, it doesn't matter. It's 3 numbers in a row. And that's an important idea for later in linear algebra. If u equals 1, 1, 0 and v equals 0, 1, 1, how could you decide if the vectors u equals that, v equals that, and here, and w equals a, b, c, I usually play music at the same time. I usually play my own music, but I should be playing other people's classical background instrumental music at the same time, and I've been planning on that, but today I forgot to. Oh well. Here's a good moment, I think, for me to take a brief little note. I fully believe live solving problems. I fully believe that live solving problems is considered fair use. It's considered fair use of the textbook material. I've seen many other YouTube channels where people are like literally just showing the pages, reproducing the pages to the camera. So this is not that different from that. It's considered fair use of textbook material. What else was I going to just say? In particular, for the educational purposes, I think it's clear that this is an educational channel. Purposes, which is like a clause or a stipulation, one of the things that can make something fair use. Further, mathematics is, you can't copyright mathematics. It's like an algorithm. It is something like the math itself is not copyrightable. Like, I don't know if the specific problem statement is or not, but even if it is, I believe that all of this is fair use. And if I'm wrong, I'm happy to be wrong. I would love to work with publishers or whatever to get clearance on that. I don't know. I'm like overly thinking this right now. Just like running through, I don't know. I hope these videos don't get taken down in the long run. What else? Also, the other thing. In particular for Strang, solutions are already online. Not just from students, but also from Strang, there's students that have posted their problem solutions, I'm sure. But also from the horse's mouth, like from like official solutions from the official MIT OpenCourseWare course. I think it was like the second running of this course, if I remember correctly. They've posted solution sets. I don't know if it's to selected problems or what. I haven't looked, but I feel like that gives me like a little bit more confidence that Strang is going to approve. Hit me up, shoot me an email, Strang. I would love to chat. I would love to thank you for this great book. And don't copy solutions verbatim. Don't copy the solutions verbatim. That's like just asking ChatGPT. You can get all of these problems solved by ChatGPT because AI is taking over the world. So the point of this channel and like working through this problem set, or of like thinking these problems through and demonstrating like how you solve the problem, the point of it is that this is the human side of mathematics, and like how, like the process of how you solve a thing or how you practice scales in guitar or something, like that's more interesting than the final result in a lot of ways, I think. Like that's my hypothesis. If you do use my videos as a hint, give credit on homework sets for anyone you work with, including my videos. Thanks. Thanks for listening to that little aside. Let's copy that again. Not easy. How could you decide if those are linearly independent or dependent? Okay, so if they are linearly independent or dependent, if they were linearly dependent, then that means that we could write any one of them as a combination of the others. Let's say W equals some multiple of U plus some multiple of V for some scalars. Scalars mean like you have a line, you have a vector and you scale it. You just stretch that vector. For some scalars A and B. Oh wait, I just used A again. But A is already in the definition of W, so I don't know. I'm not gonna use X and Y. Why not? I don't love it, but I think he used M earlier. He used M at some point. So let's do M1 and M2. I don't like N and M because to me, usually N and M mean integers, but whatever. So let's assume ABC is a scalar multiple of U. So we have M1, 0 plus M2 times V. 0, M2, M2. ABC equals M1 plus M2, and M2. A is M1, B is M1 plus M2, C is M2. So it's asking, how could you decide if those vectors are linearly independent or dependent? So I think that it's asking if W has this pattern, then they are linearly dependent. First, I should notice U and V are independent because the first coordinate are separate. You can never write 1 as a multiple of 0. So now, if W has this pattern, then W is a combination of the other two vectors. If it does, then maybe M1, maybe we can solve for the variables in terms of one another. Can I get an equation what I want to get is an equation in terms of A, B, and C. Similar to, we did a lot of math. Look at all this. I feel proud of myself. I remember math. It's been a long time, but I remember math, apparently. Similar to this equation, AD equals BC in this other exercise. So, like, really, this new exercise that we're working right now is really similar to this first exercise from the problem set. Because here, he wasn't using the terms, like, linearly dependent or independent. He just said a multiple. If the second vector is a multiple of the first vector, well, that is linearly dependent, like in the case of two vectors. In this case, we have three, so the form of the problem is just a little bit harder. So that's neat. That's cool to think about. So maybe we're doing the same kind of trick. We're going to set M1 is equal to A. So then in the second equation, we know that B equals A plus M2. And then, yeah, let's do the same thing. Taking the third equation, M2 is C, so B equals A plus C. Yeah, I think that's it. I think there's the answer to this hard problem. If B equals A plus C in the last vector, then U, V, W are linearly dependent. Hey! I feel good about that. Please, if anybody sees a problem with that, let me know. I'm open to feedback. I would love to get any feedback is a gift. I think that's right. Cool. This, I believe, is the first live solved problem in this stream. That's not intentional. I meant to get to some unsolved problems, unsolved for me, in the last ones, but we always ran out of time. So this is fun. We ripped through 10 problems. Or, well, no, we skipped a couple. We skipped 8 and 9. And I think I have to go. But yeah, this was fun. We did our first live solution. I have not looked at that problem until now. So thanks for watching. Like and subscribe. Where is it? What are we going to do? The name is The Math Hobbyist. Thanks for watching. Bye, everyone. I hope you have a beautiful day. Bye. This was fun. I'll send you an email. See ya. Yeah, see you, dude. Yeah, please do send an email. That would be fun. I'll send a couple links from my side as well. Yeah, great to meet you, Ben. Thanks for stopping by.